In this video, let us continue to solve problems based on general solution of equations reducible to the form sin theta equal to sin alpha, or cos theta equal to cos alpha, or tan theta equal to tan alpha. Alright, here we've got a question which reads like this. It says solve the equation cos theta plus cos 3 theta minus 2 cos 2 theta equal to 0. So now what we're going to do here is we are just going to use this equation in the same form as it is written. We're not going to manipulate anything. So we have cos theta plus cos 3 theta minus 2 cos 2 theta equal to 0. So now if you see this, the first two things, it is of the form cos A plus cos B, right? I'll just make a small rearrangement here. I'll write this as cos 3 theta plus cos theta, which is the same anyways. So minus 2 cos 2 theta. It's just going to be easier for me when I take this as cos A plus cos B. Because at one point, we are going to get 2 cos A plus B by 2 and A minus B by 2 and all those things. So 2 cos of 3 theta plus theta divided by 2 times cos of 3 theta minus theta divided by 2 minus 2 cos 2 theta equal to 0. Alright. So now 3 theta plus theta divided by 2 is nothing but 2 theta. So it's 2 cos 2 theta. In this case, it is 3 theta minus theta, which is 2 theta, and 2 theta divided by 2 is just theta. So it will be 2 cos 2 theta cos theta minus 2 cos 2 theta equal to 0. If you notice carefully, the problem itself is designed in such a way that, when you solve it in the right way, you're going to get enough number of cues as to what you have to do the next step. So if you see this equation, you know that there is 2 cos 2 theta present in both the terms, and you can take it out. So you have 2 cos 2 theta. Taking it out, you have cos theta minus 1 equal to 0. So now we have 2 cos 2 theta equal to 0, or cos theta minus 1 equals 0. Alright. So now cos 2 theta equal to 0 divided by 2, it's going to be 0. So don't bother writing that. Or we have cos theta equal to negative 1 goes to the right hand side, and we have 1. Alright. So now let's look into these two equations separately. So now first I'm going to consider cos 2 theta equal to 0. Right. So I'm going to write this equation as cos 2 theta equal to cos of pi by 2. The reason being cos of 90 degrees is 0. So I'm writing it in this form. So this is nothing but cos theta equal to cos alpha form, right? So the general solution for this equation is going to be, let me remind you all, what is it? It is theta equals 2n pi plus or minus alpha, where n is an integer, right? So now for this particular equation, we have 2 theta equals 2n pi plus or minus pi by 2, where n belongs to integer, or n is an integer. So now as you can see, you can take out, okay. Now theta is going to be equal to 2n pi divided by 2 plus or minus pi by 4. 2 times 2 is 4, where n belongs to z. If you see these two terms, you can take out, okay, 2 and 2 gets cancelled. So we have theta equals n pi plus or minus pi by 4, where n is an integer. Alright, so that is the general solution of this part. Now going to the second part. So what we have to take is, we need to take cos theta equal to 1, right? So cos theta equal to 1. Now we can write this as cos theta equal to cos 0, because cos 0 is what's going to give you 1. So we have the general solution given by this. So we have theta equals to m pi plus or minus 0. It's just going to be 0. Don't bother writing it. So it's just going to be 2m pi, where m is an integer. Right, so this was a simple one. So that ends this particular equation. So by that we are done with this particular problem. Alright, so that ends this video as well. So I'll see you in the forthcoming videos with more problems based on general solution of equations reducible to the form sin theta equal to sin alpha, or cos theta equal to cos alpha, or tan theta equal to tan alpha.